On behalf of Institution of Engineers and Marine Engineering Division of West Bengal State Center, I'd like to welcome all, particularly our guest speakers, panelists, Mr. S.K. Sarkar, Arun Kumar Singh, Amit Bhatnagar, and Abhijit Banerjee, our President, Vice President, and all our corporate members.
Mr. Bhatnagar, please.
Thank you, sir. Thanks, the organizers, Institution of Engineers India, and providing me this opportunity to be speaking among the stalwarts of industry and the knowledge-based organization IMU. The subject is very close to my heart, and as IRS, we had been conducting a one full day training program on this these days to make the industry aware about that. But incidentally, I will say that, Mr. Singh has covered major part of what I wanted to cover. So hopefully I'll not delay you for your dinners. With this, I'll just go through the presentation, and the duplicated portion I will skip through in faster mode, if you allow me, sir. And at the same time, I had also been seeing some questions raised by some of the participants. Probably I may be able to answer some of those questions during the course of my presentation. So this is what I'm going to cover: the background, candidate fuels and technologies, which major portion has already been covered by Mr. Arun Kumar Singh. Comparison of various fuel candidates, rules and regulations, which I will cover in very short, and then study on present active ship fleet, which also I have compressed a bit so that we can justify the timing which is allotted today. Okay. So I'll just quickly go through that. In 1988, the UN Intergovernmental Panel, that IPCC, was constituted, and then 92, the framework for Convention of Climate Change was created, and in 97, MARPOL adopted MARPOL Convention, that is Annex 6, which was that was the beginning to consider CO2 reduction strategy. Actually, that was not the time. Incidentally, MARPOL was only related to initially the polluting gases. Later on, the GHG gases were also included in that. And then in 2003, Assembly Resolution 923/23 was adopted at IMO Assembly to identify and develop mechanism needed to achieve reduction of GHG emissions from shipping. And then came EEDI, which Mr. Sarkar has very well explained. And then 2015, COP21, that famous Paris Agreement on climate change, which brought in MEPC 69 in 2016. And then in 2018, we have got IMO initial strategy on reduction of GHG gases. So this is how this is the journey, and I'll just go through which other speakers have already covered. So I need not have to revisit the whole thing once again. Now, this is what is important. When we talk about these candidate measures, it can be divided into three different methodologies. That is short term, which is initiate and research and development, activities on low and zero carbon fuels. So which has to be between 2018 and 2023. So which is already in progress. And medium term effective update, that is effective update of alternate low and zero carbon fuels, including update of national action plans. Each country has to come out with that. So this has been planned between 2023 to 2030. I'm sorry about that. There's a typing error from my side. And then long-term measures to pursue development of zero carbon or fossil fuel free combustion. So that is to be finalized and agreed by MEPC, which will be beyond what is going to happen beyond 2030. So we have got greenhouse gases. Now here what is important is global warming potential, GWP. Now when we see the concentration, we have got water vapor, which contributes to 36 to 72% and has got highest concentration. Then we have got carbon dioxide, which has got 400 ppm, and which consists of 9 to 26%, and then we have got methane and ozone. Though water vapor has got highest contribution, but the life is very short because you get rains after that. So I think this major portion was already covered, so I will try and skip this. I just wanted to show here that we have got CO2, nitric oxide, and we have got methane, which has got high global warming potential. Now, these were a few fuels which I wanted to discuss, but then my job has been, reduced by Mr. A.K. Singh. So I will just move ahead from here. I'll quickly go through. This was already covered, so I'll be a little fast on this. As far as LNG is concerned, the storage temperature is well known. You've got 106 minus 62, and then storage pressure. So now what is important here to discuss is, this is what I wanted to discuss here, that there is an extensive experience of handling LNG, because LNG as cargo on gas carriers is there for the last almost 50 years. Now IGC code contains detailed requirement as regard to carriage of LNG as cargo. Further, IGF code part A-1 deals with uses of LNG as fuel on board ship, and large number of ships have been using this without any accident, though it is considered to be very unsafe in normal terms. So what happens? CO2, SO2, NOx, and particulate matter emissions are much reduced as compared to those for conventional fuel. However, as other speakers have also spoken about the methane slip, but then the technology is improving, so this methane slip will also over a period of time should go away, or it will reduce to larger extent. Now, FAME also was discussed, so whatever has been discussed, I am not going to repeat it. I will just come towards what are the outcome of various technical discussions on FAME. That is, IRS has been proposing of use of B20, that is 20% blending, and the permission of this 20% blending has to be obtained from statutory authority as per MARPOL Annex 6 requirement regulation 3. And I am happy to share with you that my colleagues have been working on this, and the trial of B20 has been successfully completed on board ships of one of the shipping companies in India. So these are the guidelines which are available in terms of best practices for fuel oil suppliers for assuring the quality of delivery to these ships as per MEPC circular 875. Now, what needs to be done for the bunker supplier, that the supplier has to register in accordance with MS Notice 3 of 2014, in accordance with MARPOL Annex 6 Regulation 3, and the base of and diesel fuel, this has to be in accordance with ASTM standard D 6751-08. That is the specification for blending of DM grade fuels. And the test report of the sample, which has to be obtained from accredited laboratory, as being followed in terms of BDN on board. And another important factor is the flash point of B20 fuel is to comply with SOLAS requirement as well. That is required with respect to the safety. I will not go deep into this. The slide is already there with you. The concurrence from engine manufacturer is extremely important, because the engine should be able to, first thing, should be able to perform to the required power, and then various purifiers, overboard discharges, ODMs, that should also be compatible when we are using this type of fuel. And then the engine needs to be stripped down at least for the initial days. One second. Then I will just quickly go through HVO, which I think already covered. So I think I can go a little faster here. Methanol is very well covered. So I'll go a little fast. Well, as for methanol also, but as it has already been stated that, you know, the SOx, NOx, and particular matter emissions are very much less for biomethanol. Now here, when we are talking about the production methodology is also very important, because, you know, when the green fuel is to be produced, the method which are adopted to produce this fuel, those methods are also supposed to be green. Then we have got ethanol already being covered. Then DME already covered. So ammonia, ammonia is likely to be a good candidate in future. However, handling of ammonia, as already been discussed, has got certain issues which needs to be dealt with. Then we have got hydrogen, which also was covered by Mr. Singh. Now, what all measures which can be used for this? There can be methodology of onboard carbon capture. So installation of scrubber to capture CO2 from the flue gases, installation of dedicated CO2 storage tank, which would typically store the liquefied CO2, discharge of CO2 at receptor ports. So this infrastructure needs to be developed. And when you have onboard CO2 capture system, ship can continue to use conventional marine fuel. You don't have to shift over to the new fuel. Installation of scrubber system will burden the existing engine room space, and power requirements will also be affected. Installation of dedicated CO2 tank would lead to sacrifice of further dead weight for existing ship. If it has to be done. And new ships, of course, the owner may not like to have such system. So then additional active substances would be required to be stored on board for the ship for the scrubber function to capture the CO2, and then requirement of additional infrastructure at national level for safely discharge of CO2, which preferably has to be underground. So these are certain challenges with respect to onboard carbon capture. Nuclear power ship is another possibility which navies have already been using. Submarines, everyone is well aware about it. The concern are with respect to design, installation, and operational costs. The leakage of radiation, which we had seen at Chernobyl once upon a time, and Fukushima reactors, disposal of waste fuel after being consumed, reactor protection for typical hazards such as collision, grounding, etc. Steel amendment, and then what to do when you are decommissioning it. Notwithstanding that, there would be advantages with respect to clean energy sources, because there will be no NOx, SOx produced in this. CO2 may be very little, a very low bunkering frequency. Maybe you may require every 5 years or so. So, when you are going in for special survey, just add the fuel at that time. Low storage space requirement for fuel, delivery of high rated power performance. Nuclear reactor on board ships have delivered power up to 170,000 kilowatt, which as of now, no other fuel may be able to achieve. Battery power ship, there was some question also on this, and the question was raised. So I just wanted to share this news item for everyone. We have classed a hybrid catamaran, which is battery power ferry, which is first in the series of 23 vessels which are being built at Cochin Shipyard. And this is designed for shore charging and certified to carry 100 passengers, and propelled by hybrid electric propulsion system by use of lithium titanium oxide batteries. Okay. Now, there is little comparison I would like to show you here for fuel storage space capacity. Now, this is what you will have to see when you compare the equivalent fuel storage capacity which is required with respect to HFO. Now, you see hydrogen will require maximum space. Now, if you say HFO is 1, so you have got good candidates as FAME and HVO, and then you have got ethanol and LNG. So that means you have to sacrifice more of the cargo storage space on board. Now, coming to cost, here you can see that least cost fuel is LNG at this moment of time, and ammonia happens to be the most expensive fuel. Same is the case for methanol or ethanol. But probably once the technology improves, then we may have a situation whereby we will have the good candidates like methanol and ammonia may have lesser cost. Now, this is what is the CO2 emissions status under present circumstances. If you see here, FAME and HVO shows potential for meeting the IMO GHG targets. You can see the IMO 2030 line showing there. So okay. Now, when we talk about CO2 emissions, now CO2 emissions, you can see here the most alternate fuels show potential for CO2 emissions reduction that you can clearly see here. Bioethanol, biomethanol as liquid biogas along with bio-DME demonstrate good potential. Liquid hydrogen also demonstrate potential, but needs to be produced using renewable source of energy to, as I said, to make it green. Actually. Now, coming to the availability of these fuels. So when we see here the equivalent, what I'm trying to say is equivalent weight is all alternate fuel plotted versus the conventional marine fuel consumption. So LNG has adequate production at this point of time. But it is also consumed for industrial purposes and other land-based industries. Biofuel production is shared by road, aviation, and marine transport as well. And then ammonia production may be scaled up in future. But then that will still fall short because presently the production is comparatively very less. Now, there was some question also about this. Now, present-day marine engines may be amendable to use the blends of biofuel or even neat biofuels such as FAME, HVO, SVO, biodiesels, taking due precautions. Engine using LNG and methanol are available in markets. These fuels are also gaining some prominence among the industry. Engines using ammonia as fuel are under development. It is expected that such engine may be commercially available from 2023 upon verification of successful testing, which is still in process. Then marine engines using liquid hydrogen as fuel are in preliminary phase or pre-preliminary stage for development. So it is too early to make any comment about it. Coming to rules and regulations, this is what I wanted to share with you. That is biodiesel FAME. It has already been covered under SOLAS, and then various alcohols, gas fuels, and fuel cells. They have been either covered in IGF code or interim guidelines have been issued by IMO on this. Now, this is what has already been developed by IRS, which is available in public domain. And anyone would like to have some more information on this, they can download the information from IRS website. Now, coming to present fleet. The oil consumption, the fuel consumption between 12 and 2018. If you see here, it can be observed that the top 5 type of ships, we are talking about international seagoing cargo ships, consume maximum fuel on total basis. Here you can see HFO, MDO, LNG, and methanol. So it can be observed that LNG is used as fuel for nearly 50% of LNG carriers. Now, with respect to fuel used by consumer, now here you can see main engine, auxiliary engine, and boiler. The main engine is the main consumer of fuel for top 5 type of ships. For oil tanker and chemical tanker, the relative proportion of fuel consumed by boiler is higher when we compare to other ships. Now, this is the present status of present fleet which is operating. So we have got 14 ships using methanol as fuel. All of them happens to be chemical tankers. Then we have got 34 ships using LPG as fuel. These are more than 50,000 ton dead weight. Then 299 ships using battery propulsion or battery assisted propulsion. and 3 ships powered by hydrogen used within a fuel cell. And then we have got 1 icebreaker vessel, which is using nuclear fuel. Then we have got 675 ships are fitted to use cold ironing, that is shore power. Shore power, even in India, it is picking up. JNPT is the first port which is going ahead with installation of shore power, and as IRS, we are supporting that. Now here, 515 ships are container ships out of 675. Then we have got 357 ships using gas as primary fuel. This is excluding the gas carriers. And we got 236 ships assessed as ready to be retrofitted with machinery for using gas as fuel. And we have got 4,323 ships fitted with scubber technology as per the data available today. And 13 ships fitted to operate with solar power assistance, and 16 ships fitted to operate with wind assisted propulsion. Then we have got 138 ships will be battery powered or battery power assisted. Then 51 ships will use shore power at berth. 651 ships to use gas as fuel. 91 container ships, 49 passenger ships, 58 oil tankers. And these figures I am explaining you that, the world is moving much ahead of what we had been thinking. And then there is a need for this awareness to be brought into the industry. So 29 ships by Methanol, 305 ships are being fitted with scrubbers here. This is 7 RO ships with solar power technology, then 4 ships to use wind assisted propulsion, CO2 tankers, 2 of them are under construction, and then 4 of them are presently already in service. Now this is what we talk about bunkering for ships which are under construction, that is biofuel, LNG, methanol, ethanol, ammonia, and experience is available for carriage of these ships as ship's fuel. For liquid hydrogen, there's some more study is required as of now, so it will take some time. With this, I would like to conclude with the following statements. Various candidates are available to support IMO decarbonization drive. However, there is no single solution to the problem. Rather, several options needed to be explored. Alternate fuel production, as on present day, may not be sufficient to completely do away with conventional marine fuels. I'm talking about today's scenario. Biofuels are excellent fuels which have less impact on the storage requirements, can be used in present marine engines, of course, with certain modifications and operational requirements need to be addressed, and do not have significantly less energy content. However, substantially, these fuels is to be explored. Sustainability is to be explored further, as well as it may be noted that the land transport and aviation sector would also demand these fuels. So there would be a competition to use these fuels. Onboard carbon capture may be a good interim solution. However, it will call for facilities at the port for reception on board's generated CO2. Infrastructure for disposal of CO2 will also be necessary at that moment of time. It may be important to note that this is a problem which marine industry may not be able to solve single-handedly, but would rather need efforts from all sectors. And it's heartening to see that entire top of IEI is sitting today and contributing towards this cause. LNG at present is the fuel which will help to reduce CO2 emissions to an extent, and its experience is also available as fuel on board. However, in long run, options needs to be explored to generate LNG from biomass in a viable manner. Availability of renewable power generation across the globe, along with the carbon capture from industry plants on land, would play an important role in determining the emissions from the marine industry. Ammonia appears to be a useful candidate as an alternate fuel. It will also depend upon the technology on board to use it in combustion engine or as a fuel cell. That is yet to be seen. Host of biofuel developed from waste biomass are available in principle. However, their feasibility is to be checked as to whether their production can be scaled up efficiently, sustainably, and viably. The age of fleet, which is very important, is comparatively young. That is around 15 years or less. Thus, phasing out these ships from service has to be gradual. Use of biofuels or biofuel blends or LNG or onboard carbon capture may be useful to reduce GHG from these ships until long-term sustainable candidate is established. In the end, I would say the bunkering frequency would be subject to a change, considering the option such as ammonia and hydrogen would need larger fuel storage tank, as I have shown in the previous slides. It may be more important and more practical for ships to undergo more frequent bunkering rather than reserve large storage space on board. So for that, we require more bunkering ports or bunkering ports in vicinity to each other. The use of shore power supply is a low-hanging fruit, which may assist in reducing emissions from 6 to 20% depending upon the particular type of ship. However, the shore power generation is essentially required from renewable energy source or a source which employs carbon capture. This, I thank you all for tolerating me, especially delaying your dinner. Thank you. Over to Mr. Gautam Sen.
Yes, sir. Thank you very much.